Okay, we're going to start a new unit called acids and bases, and so let's talk about the difference between the two. So hopefully you already did the activity prior to this, but now we know that our acids have H's, hydrogens in the front, and bases will have OH's called hydroxides in the back. Okay, so let's first talk about an acid. An acid will increase the concentration of a hydrogen or a hydronium ion. So hydrogen, or we can call it hydronium. So if you look on the side here, this one is called hydrogen. This one is called hydronium. You just have to know that they are interchangeable. So all of these acids are generally going to start with a H for hydrogen. They usually taste sour, okay, or tart. So think like Sour Patch Kids or lemons. Those are your example of acids. Okay, on the base side, it increases the concentration of hydroxide. So hydroxide is that OH. So every time you see an OH, you're going to think of a base. There is one exception. NH3 does not have an OH, but it is a base. I would put a huge star here. It's one where you have to memorize that NH3 is a base, even though it does not have an OH. Bases generally have a bitter taste. Okay, think of like unsweetened chocolate, so dark chocolate, or things like soap. Okay, so how do we name acids and bases? Okay, so we're going to need our periodic table, and let's look at the rules here. So with acids, there are two different types of ways to name them. So we have to look at a binary acid versus an oxy acid. So the word binary stands for two. That means you know it's an acid because it has a hydrogen in the front, okay? But there are only a total of 2 elements, okay? So these are the rules. The prefix, you're basically going to start the acid name with hydro. You're going to put the root of the element and you're going to end with ic. So it goes hydro, root of the element, end with ic. Then you're going to write acid at the end of the name. So here's an example. HCl. You know that it's an acid because it has an H in the front. And now you're going to look at this element, chlorine. Okay, so you're going to start with hydro, so you know it's binary. There are 2 elements. So you start with hydro, you're going to end in ic, and here you're going to put the root of the element. So chlorine, the root is chlor, it becomes hydrochloric acid. Okay, so let's try 2 examples here. Here we know it's an acid because it has an H in front. There are 2 elements, so we know it's binary. So you know you have to start with hydro. So go ahead and write out hydro. Now, what is the element Br? So we can look at our periodic table. Br is bromine. Okay, so what is our root? It's going to be brom, and you're going to end with ic. So it becomes hydrobromic acid, like this. All right. What about HF? Try HF on your own. So you know it's an acid because it has an H in front. There are 2 elements, so you know it's binary. So it has to start with hydro. If you look back, the letter F is fluorine. So it's hydrofluoric acid. It's not flouric, it's fluoric acid. So make sure you spell it correctly. Okay, now how do you go backwards then from name to formula? Well, you know it's an acid because it will say acid here. You know it's binary because it starts with hydro. So you know it's binary. Basically, there are only 2 elements. If there are only 2 elements, okay, then you know the acids are going to start with a hydrogen. So you start with a hydrogen. Hydrogens have a +1 charge. Okay, now the iode here, iodic, okay, you have to think what element is iodic. So you're going to go back here and you're going to be like, which element could it be? It's probably iodine. If you look at iodine here, it's in the 7th column. That means it has 7 electrons, so you need to gain 1 electron to get to a full octet, so it's -1. So here, you're going to write iodine has a -1 charge. So, remember how we cancel out these charges? If you have a +1 and a -1, they cancel out, so you only need 1 of each. So this is the most friendly acid of them all. It's HI. Okay, let's try another one. It's hydrosulfuric acid. So once again, you know it's an acid, so it's going to start with a hydrogen, so +1 here. Because of the hydro, you know it's just one element, so you're going to look for that element. This is the root, sulfuric, so sulfur. Okay, so sulfur uses the full word, so that is here. It's in the 6th column, so it needs to gain 2 electrons, okay, for it to get to an octet. So we are going to write sulfur has a -2 charge. So now how many of each element do we need so the charges cancel? We are going to need 2 H's to cancel out 1 sulfur. So the formula becomes H2S. Okay, so just a quick recap before we go on to the next thing about the charges over here. You know that in the 5th column we need to gain 3 electrons. The 4th column doesn't have anything. So make sure you know what these charges are, okay? On the other side here, you're going to need to lose 1 electron, you're going to lose 2 electrons, and we're going to lose 3 electrons. So make sure you know these charges. It goes 1, 2, 3, nothing. Okay, well, I guess 0 is not really a good thing to put right here, but we can put that it's Na here, and it goes -3, 2, 1. Those are the charges for the elements. Okay, let's move on to an oxy acid. An oxy acid is when you have an acid, but it is more than 2 elements. So it's an acid, so it starts with a hydrogen, but when you have more than 2 elements, you have to look at the polyatomic. If the polyatomic originally ends in 8, you're going to change it to ic. If it originally ends in ite, you're going to change it to us. So let's go through some examples. Here's H2SO4. You know it's an acid because it starts with a hydrogen, so you're going to look at this and you're like, okay, there's more than 2 elements, so there must be a polyatomic. You're going to find SO4 on your list. So remember, your polyatomics are here. SO4 is right here, so it's sulfate. So that's what we wrote here, it's sulfate. Now, if it ends with an 8, we change it to ic, so it becomes sulfuric acid. Okay, here's another example. You know that it's an acid because it starts with an H, but now we have more than 2 elements once again, so you have to look up SO3. SO3, according to our chart here, is sulfite. If it ends in ite, if you look up here, if it ends in ite, you have to end in us. So this becomes sulfurous acid. Okay, so sulfurous is SO3, sulfuric is SO4. So let's try some examples on our own here. Here you know it's an acid because it starts with an H, but we have more than 2 elements, so we have to look for this polyatomic. So NO2 is right here. It's nitrite. Nitrite, ite, needs to be changed into us. Okay, so I'm going to write, originally it was nitrite. The ite needs to change into us, so this becomes, let me change colors here, nitrous us acid. Okay, let's try one more. Here, we know it's an acid because it starts with an H. It has more than 2 elements, so it's ClO4. So we're going to look for ClO4 on our chart here. ClO4 is here. It's chlorate. 8 needs to change into ic. So let me write the original name. It was perchlorate. 8 needs to change into ic. So it becomes perchloric acid. All right, perfect. Now how do you go backwards? Well, here you know it's an acid because it will say an acid, but there's no hydro, so we know that there's more than 2 elements. That means that there's a polyatomic. So here, you look at the name chlorus, and now you go backwards. If it ended in us, that means the original one was chlorite, because ite changed to us. So once again, we're going to have to do our charges. So when you have an acid, you know you have a positive hydrogen, right? Now you're going to look up chlorite. Chlorite is here, which is ClO2 with a -1 charge. So we are going to write ClO2 with a -1 charge. You want to cancel out the charges. You have a +1 and a -1, so you have 1 of each. So it's HClO2. If it makes you more comfortable, you're always welcome to put parentheses like this around here. Okay, then the last example here is phosphoric acid. So you're like, it's an acid, so I'm going to start with a hydrogen. Phosphoric means that original name was phosphate, because 8 turned into ic. So let's look up phosphate on our chart here. Phosphate is right here. It's PO4 with a -3 charge. So let's write PO4 with a -3 charge. So you have a +1 and a -3. How many of each do you need to cancel out the charges? And hopefully you understand that we need 3 hydrogens. We need 3 of those positives to cancel out 1 of the phosphates, like this. So it's H3PO4. You can always put parentheses here if it makes you more comfortable. Now, a little thing to help you remind you what the polyatomics changed to. So if you look down here, it says I ate something icky. Okay, now I have meningitis. I ate something icky. Okay, and I now have meningitis. Okay, so there's a little trick to help you remember. Okay, the last section here is naming a base, and bases are super simple, okay? So here, bases, you know you have a base when you have a hydroxide right here. That is your OH. So how do you name them? You just write the name of the metal and you write the word hydroxide after it. So if you see NaOH, you know it's a base because of that OH. So you write hydroxide. Na is, if you look on your periodic table, it says it's sodium, so you write sodium hydroxide. Once again here, you see the OH, so you write hydroxide, so that means Li is a metal, and you're going to find it right here. It's lithium, so you write lithium hydroxide. Let's try an example. Here you know it's a base because of that OH, so you know it's going to end with hydroxide. So that means you need to find this element on your periodic table. It is potassium. So you are going to write, it is potassium hydroxide. Like this. Okay, next, another example is, once again, you know it's a base because it ends with an OH. So you know it's going to end in hydroxide. So now we have to find this element on the periodic table. Ba is right here. It's barium. So we're going to write barium hydroxide. All right, so how do you go backwards? It's the same concept. You have to look up the element magnesium. Magnesium, according to our periodic table, is right here. It has a positive 2 charge. It needs to lose 2 electrons. So you are going to write Mg with a positive 2. Hydroxide is a polyatomic. So if you look here, every time you see a hydroxide, it's always OH with a negative 1 charge. So you are going to write OH with a negative 1 charge. So you got to think, how many of each do I need so that my charges cancel out? I need 1 magnesium for every 2 hydroxides, because I need 2 of these to cancel out 1 of these. So that is magnesium hydroxide. Let's try one more. You have aluminum hydroxide. So aluminum is going to be a metal attached to your hydroxide. So aluminum is right here. It's going to lose 3 electrons. So you are going to write aluminum with a positive 3 charge. Hydroxide always is the same. It's the OH with a negative 1 charge. And you're going to ask yourself, how many of each do I need to have to cancel out my charges? I'm going to need 3 of these to cancel out 1 of these. So it's going to become Al, OH, and I need 3 of those. All right, on to the next thing. Okay, so we are going to learn the difference between a strong and weak acid and a strong and weak base. So when you have something that is strong, we're not saying that it's like super deadly. That's not what it means. When something is strong, it means that it will completely separate, okay? So it's all about separation. So strong acid or a strong base will completely separate, okay? They will completely fall apart. So if you look in this picture right here, you look at this HCl, and all the H's and all the Cl's have separated completely. So you're going to get a hydrogen all by itself, and you're going to get an anion. It's a negatively charged particle all by itself. Okay, so here our anion is chlorine. So we have our little anion chlorine just floating around. Now, remember from last unit, if you have charges, if you have a positive and a negative charge, you can produce electricity. Remember, electrolyte, you're going to think electricity, right? And so here are 3 questions. Does it produce electricity? We say yes, because we have positive and negative charges, okay? The question is it going to have a dim light or a bright light? Well, there's a lot of charges. They all separate. So we have a bright light, and we say that this is strong because it completely dissociates. Okay, they completely fall apart. So what's the difference between a strong acid and weak acid? So weak acid is what we say partially falls apart, partially separates. So if you look here in this picture, some of the H's and F's came apart. Like here's an H and here's an F. But some of them, like here, here, and here, they stayed together. Okay? So you have your H's and your F's, okay? But you mostly have HF still together. Okay? So most of them stay together. They partially separate. So when it does separate, you do have a hydrogen and you do have an anion, meaning you have a negative charge. So if you look at your negative charge, that's your fluorine, okay, right here when it separates. Okay, so now if we answer these questions, yes, it will still produce electricity because we still have some positive and negative charges, but we don't have a lot of them. And because we don't have a lot, we say it creates a dim light because it's a weak acid. Dim light because it's a weak acid. Okay. Now, the same concept is true with our bases. A strong base will completely dissociate. They will completely separate. So if you look at this next picture right here, all the NAs and all the OHs fall apart. Okay, none of them are together. They all separate. So when you separate, it's going to create a cation. Remember, cations are positive. So here, our cation is our Na, so those are our cations, and then it's going to create a hydroxide as well. So all the cations and all the OHs are separated. So how do we answer these questions? Will it produce electricity? Is it an electrolyte? Yes, because you have positives and negatives. Is it dim or bright? It's very bright because all you have are positives and negatives because it is a strong base. It's a strong electrolyte. Anything that's bright is going to be a strong electrolyte. Okay, so here you have a weak base. Weak bases will partially separate, just like a weak acid. So if you look at this NH3 here, okay, sometimes you see them separate, like here's an OH, here's an NH4, but most of the time the NH3s will stay together. It's still the same on this side, meaning that when it does separate, you'll get a positive ion, a cation, and an OH, but a lot of them are not going to separate. If that's the case, then you are going to have, you're still going to have an electrolyte. Yes, because you have some charges, but it's going to be dim because you don't have that many positives and negatives, and we call that a weak electrolyte. So if you recap here, anything that is bright, okay, will be a strong electrolyte. Anything that is dim will be a weak electrolyte. So they will both light up. It's just going to be dim versus bright. Okay, so when you have a practice problem like this, here on the left side of your reaction, you're going to label if you have an acid or a base. And on the other side of the arrow, the right side of the arrow, you're going to identify if you have a hydroxide or a hydronium. And hydronium and hydrogen are interchangeable. Okay, so you're going to look here at number 1. You can recognize that this is water, so that's not an acid or base. So you're going to look at this right here. It has the H in the front, so you know that this is an acid. Acids on the other side will always have a hydrogen or a hydronium. This is a hydronium right here, because acids always have hydroniums. Remember, hydronium and hydrogens are interchangeable. They mean the same thing. So if we look at this next example, we look here, that's water. It's not an acid or base. So we got to look at this compound right here. You spot that OH right here, so you know that this is a base. On the other side then, a base will always have a hydroxide. Now that's not a hydroxide, but this is. So you're going to label right underneath it, this is a hydroxide. All right, so now you're going to do practice on the next page. Good luck.